Hello, thank you for checking out Mr. Ware's videos, and today we're looking at part 2 to this um, Unit 1 Quiz 1, actually Unit 2 Quiz 1 Study Guide. So this is part 2 to that. I'm going to start off here with number 12. It says a funny video is shared on social media. There's a discrete relationship, underline that, discrete relationship between the number of people who see it and the days it is on the internet. Okay? Use this information to answer the problems from 12 to 14. So it's a discrete relationship. So it gives you the little table here. It goes from 1 to 5, 5 to 25, and 25 to 125. So the first question is the relationship between days and people who saw the video linear or exponential? Okay, so if we're adding the same thing, it's linear, and if we're multiplying the same thing, it is exponential. Right? So there's no way you could add 4 to 1 and then add 4 and get 25. So it's not adding, but it is multiplication. You'll multiply by 5. 1 times 5 is 5. 5 times 5 is 25, and so on. So that's going to make it exponential. All right, next up, what is the domain for the function that models the relationship between days and the number of people who saw the video? Okay, what is the relationship between days and the number of people who saw the video? All right, so since it says that it is discrete, there we go. Since it says that it's discrete, it can't be fractions. These days are going to be whole numbers, right? So it can't be real numbers. Okay, now it could be whole numbers, but there's no day zero. There's no day zero, right? So it starts with 1. So whole numbers would include 0, right? Integers would include 0 too, and negative numbers. So that's not it either. Okay, so that leaves natural numbers or counting numbers: 1, 2, 3, 4, and 5, and so on, right? So the answer is I. All right, number 14, same problem. It says write both the explicit and recursive rule for the relationship between days and the number of people who saw the video. So you need two things to write that. You need the first term, which in this case is 1. I'm going to put FT for the first term. And the common whatever. In this case is ratio, right? Common ratio. So the common ratio is 5. That's the number we're multiplying by. So we start off with the recursive. We're going to say what the first term is. So f of 1 is equal to 1. And then we're going to say f of n, which is the next term, is equal to f of n minus 1. That's going to be the previous term times 5, because that's what you multiply it by. So if you multiply to find out the next term, to find 5 here, you multiply the previous one 1 by 5. To find 25 here, you multiply the previous one 5 times 5. So that's the recursive. And I'm put REC out here. REC. And the next is explicit. Okay, that's going to be f of n is equal to, and we're going to use the explicit formula, okay, which is the first term times the common ratio raised to the n minus 1. Okay, the first term again is 1, and I'm going to write it again. F of n is equal to 1 times 5 raised to the n minus 1. And any number times 5 is that number, so that also equals f of n is equal to 5 raised to the n minus 1. let's take a look at another one. Okay, so for problems 15 through 17, use the situation. A car rental company charges a flat fee of $20 to rent a car, plus 50 cents per mile driven. Um, you pay all the distance that you drive. Assume that the relationship between miles driven and the price of the rental is continuous. So they tell you that it's continuous. All right. So, I mean, you could count money, so you might think it's discrete, but since they tell you it's continuous, go off of what it says. All right. So I'm gonna make a table here. Now, like I said, I'm gonna make a table here, and we're gonna have the miles over here and the money over here. All right. So just to rent the car, you're gonna pay $20 a flat fee. So at 0 miles driven, that's $20. Okay. Every mile after that, 1, 2, 3, we're gonna add 50 cents. So this is $20.50. This will be 21. This will be 21.50. It just keeps going up. And remember, they told us that it's continuous. All right. Now we're adding 50 cents every mile. So since we're adding, it's going to be linear. All right. It says, what is the domain for the function that models the relationship between miles driven and the price of the rental? Okay. So we got to put in the input here. Now, since they tell us that it's continuous, it can't be anything like real numbers or all positive numbers or anything like that. Now, natural numbers would be, oh, and this says real numbers too. Real numbers greater than 0, which is basically saying all positive. It can't be that either. So it can either be natural numbers, which is 1, 2, 3, 4, 5, or it could be whole numbers, which is 0, 1, 2, 3, 4, 5. Right? We started with 0 this time. So it's going to be all whole numbers. Oh, you know what? Let me fix that. This is continuous, and I'm going off of discrete. My bad. I'm going to fix all of that. So let's go back. Continuous. So since it says continuous, we can say real numbers, but we can't say all of them because that would include negatives, right? So the natural numbers are out. All the whole numbers are out. Those are gone. It's actually going to be all positive numbers that's equal to 0 or greater. So I'm thinking it's discrete because of this, but because they said continuous, it's going to be this one right here. All right. Next, we're going to take a look at writing both the explicit and recursive. So we're going to start with the recursive. So the first term is $20. So f of 1 is equal to $20. Okay, and since they said continuous, I'm going to use x instead of n here. So f of x is equal to f of x minus 1 plus 0.50, 50 cents. All right, so that's the recursive. Now the explicit. The explicit is going to be, we're going to say f of x. And what do we start with? We start with $20. And what are we adding? We're adding 50 cents. And how many times are we adding it? X times. And that's it. That is a quick little review over the study guide. I want to thank you for checking out Mr. Ware's videos. Have a nice day.